Well, this is Sufyan. I'm going to introduce the new mining technology, which is based on the extrapolation or by extrapolation of the next, the existing uh, data of so this is actually based on the tracking where the valid block is up. So to do this, we track. We really rely each block parameters. We have to know what each block parameter or how block parameters are uh, connected by each other. So in fact, I validated this on my normal PC, which has produced already 6 billion zero, but still didn't find the right blockers. Anyway, uh, I tried to find the rates for each two parameters. Let's say it actually was the three pairs, two parameters you know. So the first was the version norms, the rates between version norms. The second rate was and the or let me say is the previous block hash and Merkle routes. And this lastly, which is the version norms, which is what we are interested on. So this I'm talking about linear relationship between. So to do the extrapolation, we have to have the linear relationship of two successive blocks. Anyway, uh, in fact, the what's matter here is what are the value of version and norms that produce the valid block hash. Anyway, to get these values, we use the continuity fractions to get the values from supplied rates. These values are exactly the denominator and numerator of produced fractions. So that's all. So let's say that I'm going to quickly let's say see its in action, by the way. So the before going ahead, so I'm going to the previous or existing mining technology is produce, let's say, non-relevant blocks. So it just gets in almost to resources. You know how it is. So it just gets in by 4K. 4 billion multiplied by 4 billion possibilities. So it's actually non-relevant. So let's go ahead how this can calculate the valid block hash. In fact, if we took So let's consider this. We have the straight line of the timestamp and the bits, the rate of timestamp and the bits. We can produce a straight line from two blocks, successive blocks. So it will be like this. This is bits of timestamp bits. One, this is I mean the this I mean here what I mean here is the decimal value. So we have to decode the hexadecimal value into decimal value. So we can I didn't actually try this, but I worked with decimal value of all parameters. Anyway, so this is the consider this is time stamp and this. And we have the empirical roots produced by the log hash. Date two log 60 produce track line like this. Not sure how direction will be increasing or decreasing. Anyway, we have let's consider with like this. So this is another step. This is the units. Units um, divided by the method rules. And we have lastly the version nodes, also similar, slightly similar to this, which we are interested in. So, if we consider two blocks, successive blocks, let's say block hash, which has this height, consider 35K as an example, and block of 35K and 1. So the next block will be the linear extrapolation of any supplied value. So we can calculate actually instead guessing, which will be focused and the performance optimized. So this is a new way. Even if we can develop it, it can reduce significantly the resources. Anyway, so if we consider or we have the selected or desired Merkle routes which relevant to desired transactions, we have also the block hash as it's known. So we can produce a rate. So if which is exactly fall in this line, consider this point. So we can how to mine or fetch this block hash. We try values instead guessing. So from the timestamp of each place of plus one block, then look through, let's say Bitcoin actually accepts 2 hours, which is exactly around 3K 60 multiplied by 2. Anyway, we consider just let's say you consider just 1K to 200, which exactly 20 minutes. So the straight line starts here on this. So we produce, I mean this, which is relevant to the selected timestamp. It actually intercepts the personal's line at this point, then this point. By continued fractions use the values of uh, versionals, then we produce the block hash. So we look through that across or next next 20 minutes. So we try about 1K 200 times until we arrive at the right block hash. Anyway, so this is similar to this. All pass through this point. So looks good. So this is a new way to mine. Instead, listen or look through, let's say, 4 billion values. So this is has no sense, by the way. So this is the next era of mining. So that's what I'd like to show in this video. I'm already, by the way, validated actually not all, so they didn't get the right proper on this one. But I guess 6 billion seconds. Anyway, so this is what I like to show this video. So I'm gonna to produce the Tenstorrent version of this. Because I have PHP version with any PC. So the issue is to produce the Tenstorrent version of this because this technology itself requires huge resources. Even I divide this into simultaneous workers, it still need IWS instances which have large amount of resources, so say 32 of RAM or similar. So, as I said, the issue is about produce the founding up of mining on Tenstorrent. Probably as you know, these students we have uh, run anything as GM Killer says. So you can, it's not limited by AI or specific use case. So I will produce this founding app or the basic mining app will be available for everyone. So not sure if it requires many student hardwares or not. That depends on the progress and uh, how you are willing to engage with it. So that's all. Thanks for watching and see you again. I hope to see you again.